Hi everyone and welcome back to Economist. So in the previous few lectures we were doing relations and functions. We have solved multiple questions on that and I have given you this to be your homework. I hope that you have tried this question and I'll start by solving them one by one and then we will see our next concept, right? So let's do this. Find the range of the function given its domain in each of the following cases. So you see the domain, the x values are given in each of the four cases. All you need to do is to find the range of the function. Okay, so let me do the first question. You just need to put in the x values here and find out the possible fx values. So do that. 1 square minus 1 plus 2 is what? It's 2. Then you have 2 square minus 2 plus 2, so 4 minus 2 is 2 plus 2 is 4. Then you have 3 square minus 3 plus 2, so it will be 9 minus 3 is 6 plus 2 is 8. Then you have 4 square minus 4 plus 2, so 16 minus 4 is 12 plus 2 is 14, right? Yeah, 16 minus 2 is 14, right? Then you have 5 square minus 5 plus 2, so it's 25 minus 5 is 20, 22. So what will be the range? So the range will be 2, 4, 8, 14 and 22, right? So it's just the values. So it was pretty simple. Let's do the second question. If x is x squared when x is minus 5 to plus 5. So we have done exact similar question in our lecture where we have studied that if you find out x square, what will that be? Square this will be 25 and x square cannot take any negative value, so it will be 0. So what will be the range? The range will be this, right? So the fx values will take the range as 0 to 25. Now question number 3. Question number 3 says if x is 1 upon x where x is less than 0, x is negative, right? So if you put negative values here, what will you get? If the denominator is negative, the entire thing will be negative, right? So what will be the range? Range will be fx values such that fx is less than 0, right? I hope this is understood. All the values, excuse me for that. Okay, so range will be all the fx values where fx is negative because the denominator is negative. And if you do the same thing here but reverse the sign, x is positive, then this entire thing will be positive. So what will be the range? Range is fx such that fx is greater than 0, right? So we have done with our homework questions. I hope you understood this. These are pretty simple questions just to solidify your concepts. Now we will go to one concept of graphs and functions. So if you are given with a graph, then you need to identify if this graph represents a function or not, right? So let's look at this particular graph. What do you see here? In the upper half, it is y is equals to x square. So this is the U-shaped curve, y is x square. And if you go into the lower part, you have y is minus x square. So this is another graph which is represented in red, right? So you need to identify just by looking at the graph that does it represent a function or not. So here what we will say is that if you look at the graph only by this particular half, only if you consider the upper half, then what do you see? For each x value you have a particular y value, right? For each x value you have a unique y value. For this you have somewhere 2, right? You have for 3 you have 9, something like this. For the negative part as well, minus 1 1, minus 2 4, and so on and so forth. So if you consider only the upper portion of the real number line, this y equals to x square is a valid function. Why this is so? Because for each x value you have a particular y value. Similarly, if you consider only the red portion, only the red graph, which is y equals to minus x square, this individually also represent a function, right? Because for the same logic that for every x value you have a particular y value, for every x value you have a unique y value, right? So if you consider individually the green function and the red function, they will represent function, right? This green graph and the red graph individually represent function. But if you consider this entire thing as a whole, if you consider this to be a singular diagram, right, singular graph, then it is not a function. Why this is not a function? Because for a particular value then you have two different outputs. For a particular input you have two different outputs. So if you consider entire thing to be a whole graph, then it is not a function. I hope this is understood. Now the second question, it's a circle. Now is the circle a graph? So the equation is something like this: x square plus y square equals to r square. So this is x, this is y, and this radius is basically r. So do you think that this represents a graph? Again, a function? Again the answer is no. Why this is so? Because for every x value you have two y values, right? For every x value you have two particular y values which are distinct, which is against the definition of a function, right? For to be a valid function, for every x value you should have a unique output or a unique y value, which is violated here. So this is also not a function. Now to summarize everything, we can introduce something called the vertical line test. So how do you know that if I give you any graph, how do you identify that this graph represents a function or not? To check this, you have something called the vertical line test. What is this test? It says that if a vertical line is moved over the allowed x values, intersects the graph exactly once. If it intersects the graph exactly once each time, then the graph is a function, otherwise it is not, right? So if you see this, you have this real number line x values. So if you draw a vertical line and move this vertical line left to right, and this intersects the graph only once, for each x value it intersects the graph exactly once, then only you can say the graph represents a function, otherwise it is not. In this particular function, this is the function. I hope it is visible to you. This is the function f(x), and if you move this vertical line for this x value, you have two different y values, so this is not a function. Similarly here also you can do the same thing. You can draw a vertical line here for all possible values of x, and if you shift this vertical line left or right, then what do you see? This line will intersect the graph more than once, twice to be precise here. So this is also not a function, and in this case also this is not a function. Now let's see some questions and try and identify which of the following are functions and which are not. So this is a oval. This is the same case as the circle. If you take any possible x value, you will have two different y values, so it is not a function. Here for each x value you have a unique y value, so it's a function. You can pause the video and try it for yourself. Here also you have for each x value different y values, it's not a function. Here also you have two different y values for a unique x value, it's not a function. Here the y values are distinct, right? For each x value y values are distinct, so it's a valid function. Here consider this point and this point. If you consider this, suppose this is x1 and this is x2. For x1 this is also a valid y value, this is also a valid y value, y1 and y2, because they are part of fx, right? Everything and y1, y2 and everything in between are part of fx. So for a single x value you have multiple outputs, so this is not a function. For the here also for a single x value you have multiple y values lying on the graph, so it is not a function. And now this is a homework question for you. I hope this is very simple to you right now, that for each x value you just need to find out if there is one unique y value or there exist multiple y values. I hope by looking at this graph you can understand that here you have unique y values, so it will be a valid graph. And that's it for this lecture, and stay tuned for the next lecture where we will discuss some of the special functions that are very useful in the context of mathematical economics. Thank you for your time. If you haven't watched my previous videos, I will give the link in the description box. You can check out the playlist for mathematical economics, and if you haven't liked my video, do like it and subscribe to my channel for further lectures, right? Thank you, and let's meet you in the next lecture.